Hey everyone, I am Bindeshwar and welcome back to Post Network Academy. So in previous videos I have explained what is variance and we have also calculated variance of individual series. When the value of x are large, so what will happen? Computing variance would be time consuming as well as tedious. So in this video I am going to explain you the computation can be reduced using technique that called deviation. And what will you do? You will replace observations by di, where you are subtracting a from all observations. But formula will also be changed. So I am going to derive this formula. So first of all, here I'm just taking di is equal to xi minus a, where a is arbitrary, you can say that assumed mean. Now take summation from both sides. So I from 1 to n di summation over I from 1 to n xi minus summation over from I1 to NA. Now divide both sides by 1 upon n, or just multiply by 1 upon n or divide by n. So basically I want to say this one. So from I1 to n di 1 upon n summation over I from 1 to n xi and this one. You will add n times a, so that would be na. Now you can observe that this one is mean of all observations and this one is also mean of all deviated observations. So I can write d bar is equal to x bar minus a. So here let us see that the variance formula, variance x is equal to 1 upon n summation over I from 1 to n xi minus x bar whole square. That is the formula for the variance. Now expand it, so 1 upon n or without expanding, just I am adding. Here I am subtracting a and adding a. So xi minus a plus a minus x bar whole square. So I have just added and subtracted a. Thereafter, this value you can write di, and this value is di, not di but d bar. So here I can write 1 upon n summation over I from 1 to n, and here di minus d bar whole square. So this may be one of the formula for a variance. And this will also reduce the computation. Now let us expand it. So 1 upon n, here summation over I from 1 to n di whole square plus d bar whole square minus 2 di d bar. So see that here 2 di d bar, and we need to prove this one. So let us take another page, and the variance of x is equal to 1 upon n summation over I from 1 to n di whole square plus d bar whole square minus 2 di d bar. Now let us distribute the summation. So you will get 1 upon n summation over I from 1 to n di whole square plus 1 upon n summation over d bar whole square, where summation is from 1 to n. Thereafter minus 2 upon n summation over I from 1 to n di and d bar here. So here I will keep as it is. Here you can see that here I will keep as it is summation over I from 1 to n di square. Here you can see that di, there is no di, so you are adding d bar square n times. So this term you will write 1 upon n and d bar whole square, and here 2 1 upon n summation over I from 1 to n di and here d bar. Now here again I am writing 1 upon n summation over from I 1 to n di whole square, and that will get cancelled. So plus d bar whole square minus this one, you can observe that is also d bar. So 2 this d bar and d bar whole square, and finally you will get 1 upon n summation over I from 1 to n di whole square minus, if you subtract 2d square d bar square from d bar square, so that would be minus d bar whole square. And this is what we wanted to prove. You can see that here, this one, and you can also write this one d bar, where d bar is 1 upon n summation over I from 1 to n di. So you can replace or you can keep as it is. So this is the shortcut method, you can say that, where you deviate or you subtract assumed mean. Assumed mean means a value you are subtracting from each observations, which is mean, and you know that if mean is deviated from the observation, so this is the minimum, and this you can say that technique we can use to reduce the large values of x, but result would be the same. So hope you understood this concept. This is just how you can reduce large values into small values, so that it would not be tedious and time consuming. and you can find out variance easily. So hope you understood. Thanks for watching the video and see you in the next video.